Hello everyone! Today we are going to explain IPv4 addresses, their configuration, and basic applications. Previously, we have talked about IP addresses. If we want to configure them in the future, it's not that the IP address is specific to a device. For example, what is the IP address of a device? Rather, it is specific to an interface of the device. Suppose we have a router here, and the router has 4 interfaces. We can configure an IP address for each of these interfaces. During this process, we need to use commands to enter the interface view and configure an attribute for the interface. We can use the interface command E followed by specifying the type and number of the interface. For example, if we are configuring the IP address for the interface J0000, we need to enter interface followed by its type G and its number. For example, if we have G001, we would enter interface J00.1. This command allows us to enter the interface view. In the future, we can configure the interface IP address under the interface view. If you have entered the interface view, you will notice that the prompt changes from Huawei to Huawei. Gigabit. 00 what? For example, if in the future we enter 000, it will display 000 here. If you enter 001, it will display 001 here, followed by an IP value. During this process, we can run this command under the interface to configure an IP value for an interface on our network device to achieve network interconnection. For example, during this process, if we want to assign an IP address in the future, we can use IP address. Like, suppose I want to assign it the address 192.168.1.1. Now, this is our IP address, and if you press enter here, it will give an error because our IP address needs to be followed by a subnet mask. For example, in this process, we can actually complete it in 2 ways. One is the usual representation of 255.2i5.2i5.0, and the other is by specifying the subnet length. This value is a number between 0 and 32. For example, in this process, after the IP value, a space should be followed by the subnet mask 255.255.255. This is how we can configure our IP value. Besides this, we can also use the IP address, for instance, 192.168.1.1, and convert the 255.255.255.0 into the subnet length, which is 24. Now, in this process, either of these 2 commands can help you configure the IP address of our interface, if during this process. Let's look at a case next. Suppose we have 2 devices here. One is our RTA and the other is our RTB. Now, in this process, we need to configure IP addresses for the physical and logical interfaces on the network interconnecting these 2 routers. The IP address can be configured not only for our physical interfaces, which are our. In fact, on our network devices, you can see those ports. Here, it can serve as the service interface for our transmission services, or as the management interface for managing devices. For example, when we refer to this port, or MJMT, or ETH management port, these are all physical interfaces. And here, this is a logical interface, meaning that, in reality, you won't see an interface called loopback on the device. We often refer to it as a loopback interface. And it is always in an active state. Once a loopback interface is created, its physical state and protocol state are always in the up state. If during this process, because it is relatively stable and won't be affected by physical interface issues or damage, it is often used as a management interface. Now, if we want to assign an IP address to a physical interface in the future, we need to access the physical interface. For the interface, J0001, we configure the IP address here. The IP address includes a subnet mask, which we can write as 255.255.255. .0 can also be written as 192.168.1.1. Following that, you add its subnet mask. Besides configuring it on the physical interface, we can also configure it on the loopback interface. For the loopback interface, we need to enter interface loopback 0, where 0 is its identifier. You can create loopback 1, loopback 2, loopback 3, and so on. This is designed based on your specific needs. Besides this, when assigning an IP address, the format and commands are actually the same. For example, IP address 1.1.1.1, and then you can specify a subnet mask length of 32 bits. Because during this process, if you set a 32-bit mask on a physical interface, it cannot generate a direct route, because a 32-bit mask means that the host route can only use this one host address. However, loopback interfaces do not need to generate other direct network segments with others. So here we can set the loopback interface to 32 bits when we are planning the network. When planning IP addresses, we need to pay attention to certain things. First, our IP addresses must be unique, meaning that every device in the IP network must have a unique IP address. There cannot be conflicts. For example, my IP address cannot be 1.1.1.1 while your IP address is also the same. If both are 1.1.1.1, it would cause confusion in the network as to which device should be accessed at 1.1.1.1. Secondly, we need continuity in our urbanized network, which is divided into the access layer, aggregation layer, and core layer. In each of these layers, we need to have continuous addresses for summarization, which is the standard practice. In most cases, this aspect is not considered in the network. Route summarization can reduce the size of our routing table in the future and speed up network computation and convergence. Next is scalability. We need to maintain the correct addresses at each layer to ensure that when the network expands, the route summarization has a continuous address space. This prevents the need for route reconfiguration due to network expansion. For example, during this process, if we want to summarize the following network segments, we can see 192.168.1.0 and also our 2.03.04.0. Now, in this process, our network segments are continuous. If in the future I need to transmit to other routes, and if I have each network segment, for example, if this router here needs to inform that router, I have 1.0 and 2.0, 3.0, 4.0, and so on. For each device along the way, it's actually unnecessary to know that you originally have so many network segments. In this process, we can do a summarization and tell it that as long as you are looking for 192.168.0.016 in the future, I have all of these and you can just come to me. By doing this, we can optimize the appearance of our routing. These are the things you must pay attention to when configuring IP addresses in our network. If you want to learn Huawei verification technology or obtain Huawei certification question banks, please send me a private message. I can also leave more comments below the video.